G'day everyone, got a question here about Review Set 12b. Question 1. Solve algebraically, giving answers in terms of pi. Sine x all squared minus sine x minus 2 equals 0. So the key to doing this one is you've got to recognise that this is a quadratic, because we've got the sine squared x, that's the same as sine x in bracket squared. We've got a quadratic here, and if we work with that we should find that it's okay. Some of you might like to make a substitution, let a equals sine x, so you've got a squared minus a minus 2 equals 0. That's fine. I'm just going to go straight ahead because we should be getting more comfortable with these by this stage of the year, so we'll see how we go. So if sine x, the whole of sine x is my variable, I just need two numbers that multiply to equal -2 and add to equal -1. So we're going to have sine x, obviously -2 is going to be one of those numbers, and +1 would be the other one. So I've got sine x minus 2, sine x plus 1 equals 0. Great. Two things being multiplied equals 0. Null factor law. We go to our null factor law, and it's going to say, therefore, sine x minus 2 equals 0, or sine x plus 1 equals 0. This one's going to give me sine x equals 2, or we've got sine x equaling -1. Now, if you remember your best friend in maths, which I'm sure you all do, this is going to be interesting trying to draw a unit circle on this. Oh, not too, that's pretty bad, but we'll say not too bad. I'll give myself a C-, feeling generous. There we go, this is my sine axis, isn't it? Sine of theta is the y-axis. So if I want to know where it's -1, it's easy enough to see. It's going to be at an angle of 270 degrees, but they want the answer in terms of pi, so obviously we're looking for radians. So remember, pi radians is 180, so it's 1.5 pi, or x equals 3 pi over 2. You could just as easily say negative pi on 2 if we wanted to go backwards the other way. That would be negative pi on 2, wouldn't it? I could go around an extra time and get 7 pi on 2. There's lots of possible answers. Was that 7 pi on 2? Yeah, I think so. Add 2 pi, which is 4 pi on 2 plus 3 pi on 2. Yeah, 7 pi on 2 would work. The one I'm interested in, though, this one here, has no solution. Why does it have no solution? Because we know from our best friend in maths, the unit circle, that the sine of an angle will be between -1 and 1. How can the sine of x equal 2? It can't. So we're left with that answer, 3 pi on 2. There could be, obviously there's an infinite number of answers, as we've already looked at these periodic functions. We're getting the idea of that. I'm trying to go down here. I'll just do it the easy way. Trying to go down and find the answer so we can see how they wrote their answer. Oh, look, they've done a beautiful thing there. What's that plus k times 2 pi? Some of us will remember me talking about that last term. Probably not. 3 pi on 2 plus k times 2 pi. They really should have had the little proviso that k is an element of z. So 3 pi on 2 is one answer. If I add or subtract pi on 2, as I said before, we end up in the same spot, don't we? So what they mean by plus k times 2 pi, I'll do k first, k times 2 pi, means I could add any multiple of k as long as k is an integer. And I don't know if they had that there. They probably did. They're a good book. They should have. K is an element of z, an integer, a whole number, positive or negative or 0. If I do that, then I've got 3 pi on 2 plus all the other possible answers. And there we have it. See you in the next video. Cheers.